Hi, everyone. Welcome to another episode of Maps and Metaphors. This is Pranav. I am right now in Perlan. That's a place in Reykjavik, and it's a museum which has amazing things about the geography of Iceland, such as volcanoes and ice caves and so on. But the more important thing right now is that I have a guest who is a geophysicist here, and I will ask some interesting questions to him. So let's get started. So could you please introduce yourself?
Of course. My name is Hakan, originally from the UK, but living in Iceland for several years now. My background is in geophysics. I have a master's degree in geophysics, specializing in glaciology, but I have, over the past few years, of course, studied volcanoes in Iceland also, and I'm currently working as a member of the museum staff here at Perlan.
Well, thank you so much. Let's get started with the volcanoes in Iceland. I read that there are like 30 plus active volcanoes. I'm not sure at this current time how many are active actually, but I'm very curious to know like why so much volcanic activities is happening in Iceland, or even in the past decade. How did it happen so much?
Absolutely. So, as you said, there are about 30, if off the top of my head, I think about 35 active volcanoes within the Holocene. So, in the past 11,500 years or so in Iceland, there have been about 35 what are referred to as central volcanoes in Iceland, which are active. And these are the stereotypical big mountains that explode and lava goes everywhere, and you have eruptions, lava flows, and ash, and so on. So these are the sort of perhaps classical or textbook idea of what a volcano is, at least 35 of these. And then also across the country, several regions of which are highly volcanically active. So these are regions which are not necessarily exhibit some large mountainside, which is obviously a volcano, but regions which are highly likely or prone to exhibit a volcanic eruption. And we can see these through mapping of lava fields across Iceland and just the overall morphology of the landscape, successions upon successions of lava flows. And these extend all the way across the country and typically are aligned with the plate boundaries in Iceland. And so some of the more recent eruptions we've had in Iceland, in 2021, there was the eruption of Fagradalsfjall in Geldingadalur, and this was this style of eruption. So it wasn't a large central volcano in the classical sense. It was more just a valley, a piece of land where the ground began to open up and fissure and crack apart, and lava started to spew forth, and this eruption lasted for around 6 months.
Oh, that one I remember. At least in the news I was following, and some of my friends were lucky enough to come here and click some pictures and get as close as possible with the possible limits. So yeah, very interesting. But I will just ask one very fundamental question, just for me and for my audience as well, who doesn't come from that background. Like, what could have caused for this volcanic activity in 2021? This eruption. Like, any guesses or any evidences from the study?
So I would hazard that the Geldingadalur eruption took place along one of these volcanic zones in Iceland, further away from what is often called the Icelandic mantle plume. So this eruption is likely caused by the overall motion of the North American plate and the Eurasian plate. As these two tectonic plates drift apart from each other, it results in a thinning of the crust of the Earth. And this means that magma from deeper within the Earth can rise up closer to the surface. As it rises up closer to the surface, it can result in partial melting of pockets of the crust and so on. and produce magmas that can then be erupted at the surface. I have to say I'm not specifically an expert on this style of geology, but as far as I remember it, what I was involved with was setting up a series of very high precision GPS stations around South Iceland, especially in Reykjanes, where the eruption took place. And we were using this to measure the signal of the ground deformation relating to magma moving up at some depth. And this gave us an idea that there was some magma movement quite deep within the earth, maybe 10 kilometers deep, coming up as a pipe, a feeder pipe. And then this produced a sheet about 1 meter in thickness, but about perhaps 10 kilometers in length. And it formed a large sheet like this, again, quite deep within the earth. And from this sheet, then the magma propagated up towards the surface, and then triggered this eruption.
Did you observe it in person? This mechanism or like this process?
So I was at the eruption site about 5 days before it happened, and we informed our decision of where the eruption was going to take place based on these GPS measurements. Also satellite measurements, so there's something called INSAR, so interferometric synthetic aperture radar, and this can be used to measure very accurately ground deformation. Geodetic GPS measurements, satellite measurements, and then also measuring the patterns in seismicity in the region allowed us to identify where the eruption was going to take place. And we were very close. And whilst I was there, actually, there was not a huge earthquake, but enough to be felt directly below our feet, and that was quite a surreal experience. It just felt like someone was punching the underneath of my boot. A very, very strange experience, but also highlighted to us like, yep, okay, this is pretty much the spot that it's going to be happening if the earthquake is happening directly underneath our feet.
Very interesting, really. Yeah, to even hear this, like I could imagine like when you were experiencing it, like in that sense, and I think it's once in a lifetime thing, probably, like at least for a normal person like me. But like if you're in this field and you're doing a study, a research around it, like you get to do it a lot often. But still, like for a lot of people, I think it's once in a lifetime thing, more or less. So yeah, that's really good to know. Let's move to another thing. I was very curious to know was about maybe you can point to give some details about the volcanic belts around Iceland, just to have some overview, and like specifically something around subglacial eruptions and submarine eruptions. If you can.
Absolutely. So in Iceland, we have a series of what are referred to as volcanic belts or volcanic zones, and these principally refer to distinct chemical signatures that are observed in the rocks that form there, and they relate to specific volcanoes. So, for example, the volcano that I've been studying over the past few years, Barðabunga, has its own volcanic system. So there's the Barðabunga volcanic system. In this, you have a large central volcano, but the system itself, so the area of land which can be fed by the volcano where an eruption can occur, is something like 130 kilometers in length. And so we have a series of these around the country. And these individual zones cluster together in terms of chemistry, and these are what are referred to as the belts, basically. So that if that gives you a bit of an idea there, it's just a way to refer specifically if someone's starting to talk about Eastern volcanic zone, it gives you an idea of which volcanoes are involved. If someone says Northern volcanic zone, then you'll go, okay, you're talking about Krapla up in the north, for example. So it's more of a a geographic term used to describe the particular chemistry of groups of volcanoes.
It's more like a system that works together, if I understand it.
Yeah, it's like a classification scheme, basically. Yeah.
Really cool to know that. I remember actually I was a couple of days back in the north, and I did had a chance to visit Krafla, and also a crater that was that's a name. That is Whitty crater. I think that's what it's called. Can you tell a little bit? Why are these craters there? Is it directly because of the volcanoes, or what is the association? And something around that.
So, if I'm not mistaken, I'm not off the top of my head, can't exactly remember where Viti is, but there are near there. Yo, you go ahead. Yeah.
I think the Krafla, like it's not even 200 meters away from Krafla volcano. It's just opposite. So if you've been in that area, I think there is a road. On the right side, it depends where you're coming from, but for me, it was on the right side was Krafla, on the left it was Viti crater, and I think there was another one which was behind it. Like I did not read any detail about it on internet, but the Viti crater was one just filled with blue water. And that was massive. Like it looked something out of this planet, and that's why I was very curious to how the craters are related to volcanoes.
Okay, so
and why is it like separate? Because volcano is like a few meters away. Maybe it was more than 200 meters. That was just my approximation being on the road. But like, I don't know. Like,
so at least the last time I was up there was a few years ago. But if my memory serves me, I think Viti is the name of the lake that has formed within the Krapla caldera. So the volcano itself is known as Krapla, and then inside of this is a big depression within the top of this mountainside, and it has filled with a large lake. And this water is mostly just from rainfall. I think it's pretty well above the groundwater table. Like Krapla is you got to go up a bit of a significant drive to get to it. So if my memory serves me, then Viti is basically the crater lake inside of Krapla, and it's mostly filled with rainwater, as far as I remember. Yeah.
Oh, okay, that's interesting. Because I think the way you're explaining it, I could think it to be one system as well, right? So it's not something separate, but like Viti could be well associated with Krafla, and it is now just filled with it. It is a lake formation.
Yeah.
And it's just filled with rainwater.
I think so.
And why the color is so different? Like it looks like some kind of a chemical, filled in there. And I'm always curious.
Yeah.
And I think it is just like me. There are many other people who would question, where does this color comes from? So do you have something to add there?
I don't have a watertight, excuse the pun, a reason for that.
That's
but
okay.
but my guess would be that from volcanoes you have a huge leaching of gases, and predominantly this is going to be sulfur dioxide, but you could also have phosphorus, fluorine, chlorine, and so on. And so very likely, Krapla erupted in the 1970s. So it's fairly recent activity, and also there's a large power plant there. So there's significant geothermal processes in the region, and I would assume this color could well be gases, volcanic gases, which have then leaking out of the caldera and dissolving into the water, resulting in this sort of quite striking discoloration of the water. But if that's exactly what's going on, I'm not sure. I'm not a groundwater expert, but that would be my assumption as to.
Yeah, I think it sounds very logical, like to have the leakage from the volcanoes seep into that, and have the color change, some kind of chemical reaction. We'll check a little bit about that. Thanks for so much of explanation. Would you also like to add something about the subglacial eruption? So does that come from inside of the glacier, if I understand it, like from the text? Or is it something else? Maybe I'm wrong.
No, I'm more than happy to talk about this. This is a fascinating process, which is extremely common in Iceland, or at least is more common in Iceland than elsewhere in the world. And this is essentially because many of the largest mountains in Iceland are volcanoes.
Mm-hmm.
Because Iceland is, results from what is called divergent tectonics. So the crust is pulling itself apart. This is not the tectonic regime that is required to generate large mountains. So if we think about the Himalayas or the west coast of the US, here in these regions we're very mountainous, and these are the result of two tectonic plates coming together, smacking together, one of them subducting beneath the other one, and the other one flexing upwards and resulting in these large mountains. We don't have that process happening here in Iceland. Instead, the largest mountains are formed by volcanoes. So even though Iceland is a mountainous country, the mountains themselves are actually not particularly high in elevation. Rarely, I think the largest mountain in Iceland, Öræfajökull, is only just over 2,000 meters elevation or so. So what this means then is that the largest mountains in Iceland are glaciers, because the elevation is highest on these volcanoes. In these high elevation regions, we have sustained snowfall year round. You require sustained snowfall throughout the year to generate glaciers, because you need to have a regime where more snow comes into the system than leaves as melt. So then the largest mountains in Iceland are the ones that can sustain glaciers, and they happen to also be volcanoes. So that means most of the volcanoes in Iceland are capped by quite significant glacial systems. So this is, for example, Katla, very famous volcano with the TV series a couple years ago, is capped by the Mýrdalsjökull ice cap, large ice cap. Much of Vatnajökull, the largest glacier system in Iceland, largest ice cap, has many volcanoes underneath it. Öræfajökull, as I mentioned earlier, Grímsvötn, Barðabunga, which is the volcano that I've been studying over the past few years. So what this then means is that when you have an eruption of a volcano, there's a statistically quite a high chance there's going to be a glacier on top of it, because that's where the glaciers are. They are on top of volcanoes, if this makes sense.
Yeah, this is really interesting. Let's please go on.
Absolutely. So if we think about then the large eruption in 2010, so the famous eruption that caused all this air traffic disturbance of Eyjafjallajökull in 2010.
I'm taking some ash as a souvenir back home.
Fantastic. Good stuff, yeah. So this eruption actually, for about a week or so before the large explosion, the eruption was just very gently effusing out of the side of the volcano. And I think downstairs in the basement of the museum, we have a nice picture of this. So the eruption was taking place and was not causing any problems for anyone, just minding its own business, just leaking out of the side of the mountain. But as volcanic eruptions are often tend to do, it starts to drift in its position. And the eruption then starts to migrate and then begins to erupt within the caldera of the volcano, which is filled by a glacier. So Eyjafjallajökull is the name of the volcano, but also the name of the glacier that caps the volcano. What happens now is you have a couple of options. Essentially, the lava is being erupted, and it starts to melt some of the ice. So you get a pocket of melt water overlain by ice, and with lava underneath being erupted, it continues to melt the ice. You get more and more water accumulating. Either, or they're not exclusive, and/or you accumulate enough water that the water pressure is enough to push all of the glacier ice on top of it upwards a little bit, becomes buoyant, and then the water can rush out of the caldera of the volcano in a massive flood. And these are known as glacial outburst floods, or in Icelandic there's a word jökulhlaup, which means a glacier run. And these cause massive floods, absolutely huge things, completely devastating. And much of the landscape of South Iceland is dominated by these huge, flat floodplains, and these are caused by the subglacial eruptions. So that's process one that can occur. The other option, which happened at Eyjafjallajökull in 2010, is that you start to melt the ice, you form lots of water, and then you start to evaporate the water. And you keep melting more ice, you keep evaporating more water, until eventually you basically have a massive pressure cooker, and it can't hold the pressure any longer.
Yeah.
And this pressure wants to find some way out. And imagine you turn the screw on top of the pressure cooker, all the steam comes out. That is essentially what happened in 2010 with Eyjafjallajökull. But instead of coming out the top, it basically blew the side of the mountain out like a massive shotgun, completely ripped apart the side of the mountain, and then all of the lava and ash and tephra being erupted from the volcano, mixed with all of this highly pressurized steam, was blasted up into the atmosphere as a huge ash cloud, and that was what was caused all of this air traffic disruption. So basically both of these processes, this huge steam explosion and also a large jökulhlaup, many jökulhlaups associated with the eruption in 2010, but more famously is the big ash cloud. Both of these processes are the possible results of subglacial eruptions.
Yeah, such a force of the nature.
Yep.
I must say, it's very unpredictable. You say like it could have gone like top, but it went sideways, right?
Yeah, it sort of just blew out the side of the mountain. Yeah.
really, really, like I could have, not imagine, not knowing, because I mean, 2010, I was not here. I was not following it, but I did not know like it went sideways.
Yeah, I mean, not exactly not exactly horizontal, but just sort of out of the flank of the volcano.
Yeah, not in the normal way that it could have.
Not the
usual trajectory, let's say.
Yes, yeah, not in the stereotype of how a volcano would look. Yes, exactly.
Yeah, I'm also curious to know a little bit about the submarine eruptions. That's like absolutely new term for me.
Yeah, so I mean, there are submarine eruptions all over the world, and in Iceland, definitely there have been some cases off of the coast of the Reykjanes Peninsula. There have been fishermen who have been sailing around that region and have reported big bubbles and bouts of foul-smelling gas and so on coming up from the ocean, and so that gives us an indication that there may be an eruption ongoing on the seafloor. There's also been some studies, like bathymetric studies using sonar and so on, where they have mapped portions of the seafloor in that area, and you can see these little mounds, maybe 100 meters or so, and that gives an idea that there was some kind of eruptive behavior going on. But perhaps more famously, it would be the eruption of Surtsey in the I want to say 1960s, but I wasn't there, so forgive me if the date's not perfect, but 1960s, off the coast of South Iceland, where this eruption lasted for so long and the output was so significant that it actually produced a whole island that rose out from the ocean. And since then, it's been considered a protected site in Iceland. No one is really allowed to go there aside from the occasional scientific team. And they use it as a sort of case study to investigate how new ecosystems develop without any input from the outside world. So it's an interesting thing, but the biologists are looking after this one, as far as I understand.
Oh wow, quite some information. I really had no idea about that, but I'm gonna definitely check more into the details of this. Thanks for sharing. Well, let's move to another. Actually, the last question. It's more about like Greenland and Iceland. I always think of. So the first time I came to Iceland, I thought like it would be as harsh as Greenland. But it turned out to be much normal place. At least you can go around, drive around, and I think Greenland is a little bit more harsh in terms of climatic conditions, a little bit more colder. But apart from that, like how are the volcanic activities linked, or do you see a relation between Iceland and Greenland? maybe something from the past and something that we can predict in the future, how Greenland was, maybe Iceland is maybe moving in that direction. I don't know. Like, is there any similarity? Please, can you tell something?
Yeah. So, I mean, the history of geological history of Greenland and Iceland is very distinct from one another. Greenland is much older, geologically speaking, than Iceland. It has metamorphic deposits from many hundreds of millions of years ago. Iceland is geologically much younger than this. However, in some of the newer strata in Greenland, there appear to be some igneous rocks sourced from volcanic activity that have a very similar chemical signature to that of the of some rocks found in Iceland, especially in the west fjords of Iceland and also in parts of the east of Iceland, which are the oldest parts of the country. And this sort of a chemical signature or similarity in the rocks is also seen in parts of Scotland also. And so I think that likely this is the idea, if we think about plate tectonics and the divergent European plate and North American plate, that Greenland and Scotland at some time were somewhat closer to each other. Iceland was perhaps not formed or started to form in some way, a proto-Iceland, if you like.
Yeah.
And so this volcanic activity, that geographically Greenland, Scotland were closer together, and the volcanic activity that was coming out of the region that soon were to produce Iceland, its signature is found in these areas also.
Yeah, that sounds very logical. Oh, thanks for your time and sharing so much valuable information. Thanks again.
Thank you very much. Not a problem. Lovely.
Okay, thanks again. And thank you, everyone. I hope you guys enjoyed it. Till then, cheers. Bye-bye.
Okay, thank you. Goodbye.